Welcome to Unit 7, Lesson 2, Transformations of Sinusoidal Functions. Previously in the course, you'd seen this general formula for transformations and translations on functions. What we're doing here is exactly the same as that. It's just that the H and K are changed to C and D. So as long as you know this general formula and what happens when you're applying these shifts and stretches, you should be able to do this very easily. Now, some things to keep in mind is that the sine and cosine base functions, they have a general shape, range. Their domain is negative infinity to positive infinity unless it's restricted. But keep in mind that the sine function starts at 0, 0 at the origin, and the cosine function typically starts at 1, the cosine function typically starts at 0, 1, and they have a range of -1 to +1, oscillating back and forth over the x-axis. So it's very easy to see how the translations and transformations have happened on the sinusoidal function. We have two terms we need to know. We have vertical displacement, and then we also have a phase shift. Now the vertical displacement D, this is equivalent to K in our original transform function. So this is your shift upward. Now when we're doing the vertical shift on a sinusoidal function, what you're going to do is just find the middle line. I'm just going to show you on the graph down at the bottom here. So if you have this regular sine y equals sine x function, the middle line is what cuts the function right in half. Up here you can see we have a median line at 3, that vertical shift. So to find that, what you can do is take the maximum plus the minimum values and divide it by 2. But if you're looking at the graph, it's pretty straightforward and simple. Just find the middle of the function. If you're solving for the maximum point, it will be equivalent to D plus the absolute value of A, and the minimum point is D minus the absolute value of A. You can also solve for D by taking the maximum or the minimum point and adding or subtracting the absolute value of A. That will also give you D. So there's 3 ways you can find it. You can use that formula right there, y equals max plus min divided by 2. You can find the maximum and minimum points, or you can just visually look at the graph and find the halfway point. The other translation that we can have is the phase shift C. This is equivalent to H in that original function. So this is our left or right shift. So when you have the value for C, it's either going to move left or right depending on the value. So we have an example here. It says, graphically represent y equals sine x minus c plus d. So we've left a and b out. You already know how to do those horizontal and vertical stretches. So it says draw the graph of the function y equals sine x minus 30 degrees plus 3. This tells you that your x-axis is going to go up in degrees instead of radians. And what I've done for you here is draw the base sine function in so that you can see how it moved. Now, typically the sine function starts at 0, 0, but it's shifted over 30 degrees and then moved up 3 units. So that starting point for that sine function is now right here. Okay? And from there you just graph out the sine function. This one has no horizontal or vertical stretches, so it's just going to move up and down 1 unit. So to do that, you want to find the maximum and the minimum. 3 plus 1 equals 4, and 3 minus 2 equals 1. The domain and range. So the domain, of course, is negative infinity to positive infinity. It's a periodic function. It just continues on indefinitely. The range is what's going to change. So you can see the range in the original function is -1 to +1. Here, Because we've moved it up 3 units, 1, 2, 3, the minimum is now at 2, and the maximum is now at 4. In C, just using the vocabulary that we already know, describe what happened. So it's been translated up 3 units. This is the vertical displacement D, which is equivalent to K. And then it's also been translated 30 degrees to the right, or a phase shift of C, which is equivalent to H. This is all stuff you already know. As long as you know the basic shape of the sine and cosine functions, then moving and stretching should become very easy. Again, you can also use those mapping points to help you determine that. So in this example, what would happen to our mapping points? We would have our x values plus 30 degrees and our y values plus 3 units. So if you start at 0, 0, you can just apply those shifts there. Beyond this, you have some practice questions, and you can map out and draw the functions that are given to you.